All right. Hang tight. Let me just get this link out to everywhere. Post. Hello. Give me just a second to get this link out to everywhere. Spindle TV exclusive. Paste. Post. One more. Spindle TV subscriber group. Paste. Post. Okay. So let's see if everybody comes back. All right, let's see if everybody comes back. Hello. All right. Let's go back to sharing our window. Okay. We can go back to, I think, Troy, I think I'm gonna I'm gonna go into my dashboard and see if I can set that as a default. I haven't seen anywhere, but I'm gonna dig and see if I can find that. Yes, Stephen. Yes, 1080p. That's the highest they have. They don't have 4K or anything like that. But that's I hate when I forget to make that switch. I am going to look for it when I'm setting up to see if I can find that in as a default where I can set it and so it doesn't change back to that 720. All right. So, ladies and gentlemen, for a moment there, we were streaming at a lower quality, and we were talking about wasteboards. We were talking about this wasteboard that you see on the screen. This is my latest or earliest design of 2023 for the digital woodcarver CNCs for the 2440s and the 1824s. It could be adapted to any CNC machine. But what I was saying before we relaunched this new stream with a little bit higher resolution is there's a lot of steps involved for someone that's new. There's a lot of steps involved on making this wasteboard because there's the surfacing toolpath, which is first. After that, the 1/4-inch end mill goes through and mills all the entry holes and all the slots. And then after that, a T-slot bit goes in and it drops into the slots and it cuts the slots. It's all set up and everything. And then all the pocket holes are cut for the fence pieces. And then all the fence pieces are cut out of a separate board. All the fence pieces are cut out that fit in there. And so there's, for a newbie, for someone that's new and everything, there's a lot of steps involved to make this wasteboard. And sometimes it can be pretty intimidating because, if you look at when they open the files, right? If they open the instructions on the files, they have instructions that basically kind of give them the idea of what they need, what size material they need, and everything to do the setup, right? And then from the instructions, there are 6 toolpaths that get run. They're all laid out. But if someone was to look at the design in the Vectric software, the instructions are also written over here. But the layout, let's switch over and make this sheet active. The layout looks insane. Now, if we go to our layers here, everything is broken down into layers, right? So the notes, the dimension, let's start from the bottom, the grid lines, the T-track pass, the entry holes, the fence pocket holes, all the way down to the surface area, the MDF board, the limit switches, all the fence layout, and then the actual T-tracks in the table. So the T-track holes, then the T-tracks in the table, and then you're back to a blank slate, right? There's a lot going on there. Now that is just the main layout of the design, you switch over to sheet number 2. This is the sheet that the tool paths are actually created off of. And then sheet number 3 are the fence parts, right? And again, it's a great wasteboard. I use it all the time. Oh, not that one. Let's go to this one. Great wasteboard. I use it all the time, but there's a lot going on. So tonight, I want to make a simpler wasteboard. I have a reason for this because one is I just give me just a second. Mary Beth, did the dog come in? Okay, wonderful. I have an alternative reason for this. One, make a simple wasteboard that even the newbie, right, that just bought a machine that doesn't know anything about a CNC, they can make without a whole lot of like, ooh, that's intimidating. That's a lot of stuff going on, right, and everything like that. Number 2, I want to, on my particular wasteboard, the way it's going to get laid out and everything, I just have on my 2440, I have the Storm black box Storm vacuum. And so this is going to allow me to kind of build in my plenum for my machine without building up too much material. I only have a certain height of travel on the 2440. Now I have 3 machines. I have 4 machines. I have the 1824 mini carver. I have the 2440. I have a 48 4x4 CNC, and then I also have a 4x8 that's not a digital wood carver, but so I have these machines, and I have different sizes. And so this wasteboard that I'm about to make, while I'm designing it for the 2440, because right now that's kind of what I need it for, my immediate need for it. It's something that I can adapt, or anyone can adapt to make it for bigger machines and all that stuff, right? So I'd like you to join me as I go through. Now, we're going to be using SketchUp. As you see here, this is SketchUp for the initial layout. And and then I'm going to looking at the parts, right? There's some things that have to be ordered. I'm going to actually be using aluminum T-track in this and stuff. And I want to talk to you about, the T-track kits and all of that stuff. I have no affiliation. There's no affiliate links or any of that stuff with what I'm going to be showing you for the links and the packages and all that. It's all stuff that I just sourced. And I haven't even finished completing sourcing everything yet. As far as the screws and nuts and bolts and stuff, I got what I have on hand, and I want to be able to utilize that. But I want to have a discussion with you all, and so you can see my process, right? The process that I'm making this wasteboard. I don't have a design right now. I have a design visually in mind, but I haven't made one. I haven't drawn one up. We're going to draw it tonight, right now, and all the way down to creating and drawing the T-track from scratch, right? Okay. All righty then. So first thing we're going to do is this SketchUp. I want to be able to use the table design. So what I'm going to do is I'm going to take my mini carver table, and I'm going to hide that because we're not focusing on that right now. I want to focus just on this 440 tabletop. And on this 2440 tabletop, I'm going to take, whoops, hold on. Let me do it this way. I'm going to hide this original wasteboard. All right, that leaves me with a blank slate. This is the digital wood carver table with its integrated T-tracks as it is, all laid out and everything. And so this is what the tabletop looks like. Again, what I'm doing could basically be laid out for any CNC. So let me talk to you first. Let me bring over some screens and everything, and let me talk to you first about the T-tracks that I'm going to be using, and we're going to draw out and create the T-tracks and all that stuff here in SketchUp. So the first thing we're going to talk about is the T-track. So this, let me hide this here. This T-track is a 4-pack, 48-inch long T-tracks. That's how long my CNC is. 48-inch long T-tracks, 4-pack. They can accommodate both 1/4 inch and 5/16 inch T-bolts. It's a universal type T-track. The T-track body itself is about 3/8 of an inch thick, 3/4 of an inch wide. Okay, and pretty simple design in itself. Nothing really crazy. We're going to draw that out, and we're going to draw that out and get it kind of laid out. So we'll make this design here in just a moment. So this kit, 48-inch 4-pack, right? $43. So I'm about $45 for that 4-pack. It's a very affordable. And there are different pieces that I could get, like if I wanted to go crazy and make, cross sections. There are parts for stops and everything that I can use with this T-track. So Amazon has kind of like, it's all pretty much assembled with the, hold downs and things like that. A 48-inch 2-piece, if I need an extra 2 pieces, another $27, right? If I want 5 or 6 T-tracks instead of 4 T-tracks or whatever, right? I do not have a design in mind, but this is what I am using. This is going to be the actual T-tracks I'm using for this project. Okay, and I haven't decided if I'm going to go cross sections where I need, the little cross section kits or any of that stuff. I haven't decided any of that yet. Basically, let's mute this so I don't get flagged for anything. But on the cross section, don't even want to watch the video. If we cut in those cross sections, they fit in there, boom, and then the other T-tracks butt up against them, blah, blah, blah. You guys have seen Craig's tables and all that stuff as woodworkers and all of that jazz. That's what we're dealing with. Okay, that is the kit that I'm using, and that's it. So that's it. Enough said. Now, this here, that's going to be the dimensions I'm going to be working off of with to draw in SketchUp to lay out the T-track. And yeah, so that's going to be that. Now, what on this particular machine, now my other machines, I have a good Z travel. I have good height and everything, but my mini carver, 1824 mini carver, I only have 4 inches of clearance. Z travel. In the 2440 only has 5 inches. In my case, I have 6 inches because I have 1-inch riser blocks. So I have 6 inches of travel. So not a whole lot of travel. So I don't want to be stacking up, 3/4 inch MDF for building things up, right? I want to kind of keep my wasteboard thickness to a minimum, not go too crazy or anything like that. And that will give me the ability to do what I want to do, right? Okay, so that being said, so you don't use dogs and wedges? No. I have on my older wasteboard, I had cam clamps and everything. But no, I just use, I mostly nowadays use the painter's tape and CA glue for hold down, or I have low profile clamps. Here, hold on a second. Let me see if I have. Yeah. So in the camera, let me go big here. Go big or go home. Hold on a second. Let me bring myself back up here for a moment. There we go. So I have side clamps, low profile side clamps and everything that go into the side of the piece. So it clamps on the side. So the top is free and everything. So I'll use those. And then sometimes I use clamps, on the clamps that I have on the top. They look just like this. If I undo that last, I have a file for making these hold downs, and they have another bolt in the back for jacking up the back end and stuff like that. So I have that file as well, and each digital wood carver customer gets that file. So let me just real quick, you can't see what I'm showing you. Let me show you what I'm showing you. Can't see what I'm showing you. Can't see what I'm showing you. Let's do this. All right, so this is that clamp that I'm talking about. So I have these clamps here that I make on the CNC. Let me show you what that file looks like, and let me show you what that file looks like. Stand by. Let me see. Not going to be there. Where is my P? There it is. PNC file folder. Master files. Master files. Let me copy this and just throw it in downloads. All right, and then let me extract it. Okay, so here, if we go into, let's open this up in Aspire. So I have a sheet of clamps here that for the cutouts, and then if we look at some images, there's a bolt on the back that has a foot elevator bolt that elevates the back end. I don't think it'll let me jump from one to the other. Basically, this style clamp here, that's what it looks like there. Let's see here. You can kind of see that. And so it uses these threaded inserts. That's the kit right there. It comes with everything you need. The knobs, right? Little 3-star knob. And the T-bolts, right? So now, in here, basically all the instructions along with the links to those threaded inserts, the bolts, and all of that stuff, right? That's kind of like a little file that that we give to each digital wood carver customer, and for those clamps, right? Easy peasy. So let's minimize that. Let's go back to SketchUp. So those clamps, the low profile clamps. Now, someone just asked me about the low profile clamps. The low profile clamps, They are made by, I'm not good at pronouncing names, Genmitsu. Same people that make the Genmitsu CNC. It's like the Sane Smart, CNC and everything. So you can get those low profile clamps on their website. And eventually you'll be able to, hopefully one day in the future, order them directly from me. But that's where they're from. Okay, so all right, with that being said, now, once again, let me redo the hide, edit, redo that hide, get rid of that. Let's start off with just creating the sheet of MDF. And we'll talk about the sheet of MDF, but I want to talk about now, I showed you the T-tracks, right? Now, here's the deal with, I'm going to try to keep this as organized as possible. I showed you the T-tracks. Now, here's the thing. We all know that when it comes to clamping, sometimes clamping force, we don't want, I'm using MDF for the wasteboard. I'm going to be embedding a T-track into this MDF. MDF isn't the strongest and everything for holding screws, right? So this particular T-track that I'm using, it calls for number 7 screws by 5/8, right? Number 7 by 5/8, blah, blah, blah. And yeah, I'm not putting a wood screw in this. I'm putting a machine screw in, and on the bottom side of the wasteboard is going to be a T-nut, so that my machine screw is going to be threaded into a metal T-nut, and it's going to be more secure. I'm not going to have wood screws in there pulling out just because I decided to get a little heavy on the clamping, right? I need something that's strong. And so with that being said, let me find my mouse. I lost the mouse. There we go. Let me find the mouse there. All right, and let me bring over another screen. Now, I want to try process. Okay, I'm thinking about the process. I manufacture and make dust brushes, so I have materials on hand for that, and I'd like to use some of the stock that I already have on hand. One of the items I have on hand in abundance are these M5 T-nuts, and they are ideal for me because they are very low profile, 1.5 millimeters thick. Well, 3.5 millimeters thick when you count the little stud and everything. They're about 10 millimeters wide. Very, very low profile. So if I decide that I want my wasteboard to be thinner than 3/4, for whatever reason, you'll see what I'm talking about, my layers. There's going to be a couple layers, but if I want things to be thinner than 3/4 and I want this T-track embedded in, remember this T-track is 3/8 of an inch thick. I can't have a big old bulky T-nut or threaded insert, that's like, 5/16 thick and all that stuff. I need low profile, short screws. So with that, the screws that I'm going to be, let me minimize that. The screws that I'm going to be using, actually, I minimized the wrong thing. Let me go back to that. Here, the screws that I'm going to be using are, let's see, M5 by 10, and it's not, this is what I have on hand, but I'm going to find a smaller one. All right, so let me come down. Okay, so I have these on hand, right? But it's a cap. It's a button cap. Can't have that. I want a flat bit. I want a flat machine screw. Number 7 wood screw is what they're calling for. So that gives me an idea of what the hole size is. 5/16 for the head size. 5/16 inch diameter for the head size. It gives me an idea of the angle, most likely 82-degree angle on that number 7 flat screw, between 80 to 82-degree head angle. And then the opening diameter of a number 7 screw is not 5/16. It is the give me a second here. Uh, 5/32. Sorry, 5/32. So 0.151. And so all that being said, I want a machine screw. So I need to find kind of an equivalent of a machine screw that will give me a flathead. I need a flathead machine screw with at least, 5/16 diameter or smaller head, because the holes that are pre-drilled in the T-tracks, right? So going back to the T-tracks here, on the holes, they have that angle and everything. In our machines right now, we use like these little button heads in the T-tracks that are integrated in the table. And sometimes they could interfere with T-bolts and stuff sliding through. So I want to try to keep this all flat and clean, right? I want to be able to use my 5/16 or my 1/4-20 hex head bolts, T-bolts, and everything. I want to be able to use all that without any interference. So I want to try to find the equivalent. And again, this is my process, right, ladies and gentlemen? Sorry I'm talking so much, but this is the design process, right? So let's start off with getting a piece of MDF drawn on the table, get it thrown in there, and then let's draw the T-track. Let's get the whole layout, the whole placement laid out and everything. Just so you know, for a 48-inch T-track, there's 12 holes, 2 inches off the end, and then 4 inches on center, spacing all the way across, total of 12 holes in one of those 48-inch T-tracks. So we're going to draw all that out in SketchUp. We're going to make that T-track from scratch, and we're going to do that actually right now. Okay, so let's get this up on the screen. I'm going to drag this over out of my way, and I'm going to have it over here so I can see the dimensions as I go. All right, let's start off with, first of all, let's get a piece of MDF on the board. And so I'm going to draw a rectangle and hit push pull, and I'm going to pull up a piece of 3/4 inch MDF here. We're going to, let's come in here and triple click on that, G for group, to group that together, and heck, we'll even give it a bit of a color to kind of represent, give it a little bit of a contrast there. Okay, so now let's go ahead and create the T-track. I'll kind of do this over in white space over here, and then we'll lay it into the table, or see what we're going to do and all that stuff. All right, so I'm going to be drawing the T-track. I'm going to be drawing the button head, not the button head screws, but the T-nuts. And the T-nuts come in different sizes and all, but I want this M5. I want to kind of stick with that because I have an abundance of them, unless I need to change out if I can't get the screw size just right. Okay, so let's do this. We're going to start off with a rectangle. Okay, and we're going to, this rectangle here for right now is going to be 3/4 inches wide, and the length really doesn't matter. I'll just do this for right now. We're going to stretch it out in just a minute, but I want to make sure that we're at, let's go 15, 0.75. There we go. All right, push-pull. Now this T-track is 3/8 of an inch thick. So I'm going to pull it up and type in 0.375 and hit enter. So that's kind of the raw blank on a 15-inch long piece of this T-track. Okay. All right. Now let's go ahead and get into kind of a camera standard view. Let's go from the front. Oops. Let me zoom out and see where I'm at there. Actually, it's going to be camera standard view right, the right side. There we go. And let's zoom into this here. All right, now I'm going to use guidelines and tape measures and all that stuff to help me out, blah, blah, blah. But first thing I'm going to do is I'm going to use a guideline and I'm going to find the center of my part, right? 3/8. Now from there, the opening where the T-slot goes is 3/8 of an inch. So therefore, from one side, we're going to go 0.1875. 0.1875. Okay. What am I trying to do there? 0.1875 is, half of the 3/8 is what I'm trying to tell you. And so that's going to be that. Now, from the bottom up, we're going to create a guideline that is 9/32 up. And so that is drag up. Oop, let me hit undo on that guideline. Drag, get the mouse where it draws a guideline in there. That's important. We're going to come in and just type in our height. Now I see my 1/4 inch dimensions and all that stuff and everything at 5/16. I can just drag it to where I think it, goes or where it's supposed to go, but I'm just going to type it in. Okay, so 9/32 is 0.28125. So 0.28125. Hit enter. That's going to be there. Now, from there, we have another height of 5/32. And so we have from the bottom again, come up. And that's going to be 0.15625. And then hit enter. Okay, so that's that one. Now, from the center, we have a 7/16 inch opening. We have a 9/16 inch opening. And we have a 5/16 opening. So let's start off with what do we want to start off with? Let's start off with the 9/16. And so we have from our center line, I want to kind of start drawing some of this in. All right, let's draw some more guidelines here. I just don't want to get too many guidelines where it gets overbearing for you all. But we're going to drag a guideline out to the right from our center line, and we're going to type in 0.28125 again. From the center line, 0.28125. All right, let's start drawing some of this in real quick. So we're going to have an opening here, and we're going to have an opening here. Now let's push pull this. So P for push pull, and let's get rid of that. Okay, let's P for push pull, and let's get rid of that. All right, so that's going to be the basic slot. Okay, now with that, I'm going to go ahead and get rid of the guidelines. So we're going to edit, delete guides, get rid of those and everything. All right, I'm going to make one new guideline right at the center of the part. Okay, that way I can put in, so that was the 9/16 opening, that's the widest opening. Now we have one that is 7/16, right? So we have an opening that is 7/16, and let's see here, we want to drag a guideline over 0.21875, 0.21875. All right, now the height of that 7/16 inch opening here, it's going to be that lower level. That's what gives us that ability to use the 1/4-20 or the 5/16, right? That dual thing. This is 9/30 or 5/32 here from the bottom of our part up to here. Well, halfway, that is going to be our the bottom of this 9/16 inch opening, or I'm sorry, 7/16 inch opening. So we're going to go, what I say, 5/32, and that's, if we drag this up, it's going to be 0.078125. And so now we draw a rectangle here. Wait. Hold on, somebody's messing me. Let me make sure nobody is alerting me that you can't see something or something. Okay, no problem. There we go. Now I thought somebody was saying, hey, we can't see, or something like that. All right, let's go here. Wonderful. All right, so we're going to, this one, we're going to draw a rectangle here. And then that's going to get push-pulled. So P for push-pull that all the way to there. All right. And then right in the kind of like in the there's a small little V groove area and everything kind of in the T-track. Let me see if I can see it in the picture. Let me see if a picture has. No, the picture doesn't even show it. So we're not even going to even bother with that. All right, so that's going to be our T-track. So now we need to extend this first T-track here. Let's get into here. Originally, I drew it to be 15 inches long, right? So I need it to be 48 inches long. And so the push-pull tool, I'm going to come to the back, hit the escape. Escape. Come on now. All right, let me get out of it. Come on. All right, on there, the push-pull tool, I'm going to hit P for push-pull. Oh, Lord have mercy. Come on now. There we go. Click on that, P for push-pull. I'm going to drag this out just a little bit from where it was, and I'm just going to type in the number 33 and hit enter, and that'll throw it 33 inches. And if I go back to my tape measure and measure from this end to this end, I should be at 4 foot. Yep. Okay. Now, triple click 1, 2, 3 to select all of that and hit G to group it together. So now it is one group. Let's get rid of the guidelines. Edit, delete guides. And let's give it a bit of a, so it's not, let's move it over. Up here for just a minute. Let's give it a bit of a silver color. Let's go with metal. Let's go with aluminum and paint that up. Let's go with a little bit more kind of like a brushed aluminum. There we go. All right. So now, let's see what questions might have popped up from you all. Let's minimize this. And yeah, CA glue and tape, but use dowels for registration. Exactly. All right, good job. So let's move this back over to the middle of the table. Let's go to camera view right. So we're kind of straight on view here. I'm going to orbit this down to kind of be like a slight isometric view, just like that. All right. Now, before I go crazy making copies and laying these out, I need to lay out my holes, right? So let's first of all, let me move this. I'm going to move this over here just for right now. But let's kind of get a little bit of a top view. Kind of like camera, standard view top. There we go. Let's drag this over just a little bit. Don't need to go too far. All right. So in a group, in a grouped object, I need to double click on it to go into it, right? I'm inside it. So I'm not, so I'm adding to that component, if you will, that grouped component. Now I'm going to use my guideline here. And I'm going to lay out a guideline 2 inches, right? From the end, it's 2 inches from the end. And I'm going to draw in that 5/16 inch diameter hole. The hole, once again, kind of referencing that, the head diameter, sorry, on a number 7 screw that they're calling for is 5/32. Let me look at this. Number 7 screw, the head bore size, it's saying 5/16. I don't know how accurate that is. The shank hole is 5/32. So the head size is 5/16. 5/16. And that's what I want. So now, when we get to the part about making the little taper and all that stuff, if I'm going to draw this accurate and everything, I'm not really the greatest at tapers yet. So don't, we're going to be a little fiddling around on that particular hole. But let's do this. I want to be centered here. So I'm going to take my tape measure, and I need to really kind of be down in here. And I really kind of need to be, bear with me a second here. And I'm going to kind of pop over to the center. And I'll do it here, actually. Okay. That's going to be my center mark right there. Let's get back into camera view top. Let's pan or drag that over. All right, now when we're drawing circles in SketchUp, you're drawing the radius, not the diameter. So 0.15625. Hit enter. Okay, now the shank diameter, which is kind of the whole diameter, is 5/32 on a number 7 screw that they're calling for, right? That's what they're calling for. And it's 5/32. So I'm going to assume that I don't have one of these T-tracks in front of me, but I'm going to assume that's what size the through hole is, the through hole. And so let's draw that. And it's going to be 0.078125. Okay. Wonderful so far. So far, so good. Now, on the let me tilt this a little bit. Let me tilt it a little bit. Let me drag it down. Again, I'm not great yet on making the cones and all that good stuff, but let's go push pull. Okay, this is going to push all the way through the part. So, and I should be at half a 5/32. What the heck was that number? Let's do this. 0.078125. There you go. Yep. Okay. So there's my through hole. If we, hold on. I'm in the table now. Okay, wonderful. All right, if I took, let me get out of that for a second. Okay, on this here, all right. I do not know exactly, I'm going to use the move tool. I do not know exactly how thick. I know it's an 80-degree angle, blah, 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 all of that happy jazz and everything, but I'm not 100% sure how thick the bottom hole is. And so on that cone there, I don't know how much material, that was just a guesstimation and everything, but let me show you how I did that. So basically on this inner hole here, we're going to pull it down to however deep the, it should be now. It just snapped to a 16th, right? So it snapped to a 16th. It could be more or less, if I leave it there for a second and I measure from the bottom up here. Let's try that again. It's reading 0. That's not true. Let me see how deep this is. Yeah, so that's a 16th. So I don't want to move down a 16th because that is 0. It's reading 0. I don't know why there's an extra lip right there, but let's push pull that just a small amount. I wish I could type in like 80 degrees and blah, 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 and, you know, I get the right height, but it doesn't tell me on the screw heads, it doesn't tell me the head height. Now, one measurement shows 0.118 3 millimeters, but I don't know what screw head that is and everything. So I wish I had that number, but I don't. So I'm going to just come in here and I'm going to bring it down a second. So 0.03125. There we go. And then I hit the M key for move, and grab the outer ring and move it back up to here, to that outer lip. And what that does is it creates that countersink effect. You see that? Okay. Now I'm not gonna waste time. This is not important to me. Hole placement is all the angles and all of the whole head and all that. That's not important to me right now. Hole placement is for sure, because that tells me where my T-nuts need to lay out and all that stuff. But this is, I just wanted to show you how to do that. Like I said, I'm not the greatest at it, but it's a pretty simple process. Figured if you're ever drawing in SketchUp, I wanted to show that to you. All right, so you should be able to see that countersink there. It's a little countersink, all that good jazz. Now, on this here, let me come over here. Let me go to camera, standard view, top. Let me get straight on with it. So on this part here, if I try moving this, it's moving my entire T-track and everything, right? It's moving the entire T-track and stuff. Don't want that, don't need it, don't want to screw all that up and everything, all that good jazz. So I don't want to select my head and all of that stuff. I simply want the two vectors. I want the ring and I want this ring. And I should be able to move that without changing anything. Well, it's wanting to grip over the hole. So let me undo the countersink in the hole, just so I'm back at the vectors. Give me just a second. There we go. Let me get the holes laid out first, and then we'll countersink them all and all that stuff, through hole them all and all that, all in one shot. All right, so once again, camera view, standard view, top, so I can see this from the top. And we're going to create a, oh, God dog it. We're going to create an array. So I'm going to select this here. We're going to move it, moving a copy, holding that control key down. I'm going to move it straight across, and I'm going to hit the number 4 on the keyboard, and it's going to move over 4 inches. Okay. Now I'm going to hit the number 11, because remember there's 12 holes. I'm going to hit the number 11, but I'm going to hit the letter X in front of it. So times 11. So that 1 4-inch move, X11, enter. And that's going to lay out the rest of the holes. And when it's all said and done, from the center of this hole to the end, I should be at 2 inches. Right? Okay. Cool beans. So there's the holes. Now, I'm going to go through and select all of the inside holes, all 12 of them. If you have a roller wheel on your mouse, pushing the roller wheel down like a button allows you to drag your parts left to right, blah, blah, blah. Up and down. All right, now with all them selected, P for push-pull. And we're going to push this down all the way through. And that was 0.078125. Okay. I believe that's what that was. If I hide this wasteboard so I can see underneath, I should have a through hole. Let me see here. Hold on. I'm in my board. I should have a through hole right there. Perfect. Okay. All right. So that's that. Now, go back into camera view top. Stick with me. Stay with me, ladies and gentlemen. Oops. I lost my push-pull because I wasn't paying attention. I jumped ahead. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, one more time. P for push-pull. Don't hit undo like I did last time. Push that down and 0.078125. Okay, now that's done. And why didn't it do all the holes? What? It should have done them all. Okay. Let me see why it's not registering. Let me get rid of that guideline. All right. P for push-pull. See, that push-pull is not... Well, first of all, it's not recognizing that inside vector. Or that one, or that one. Hold on a minute, ladies and gentlemen. Well, okay. I'm going to drag them separate instead of both together for some reason. I don't know why. That's a new one on me. For some odd reason, it kind of grouped them together, and it's not registering the inside. So no problem. I should be able to, that one's reading, so they're separate there, so that's good. Let's do this one more time. So I'll do one at a time. M for move. Grab the control key and drag that over. Hit the number 4 and enter, and then X11 enter. Okay. Let me just see if I select this and that. Let me see if it'll let me do 2. Push, pull. Huh. I thought it used to let me do more than one at a time. That's all right. We'll quickly do this. 0.078125. Okay. Let me get this middle circle moved over. Hold down the control key. 4 inches, and then X11, enter. All right. So I'm gonna really quickly. Sorry, let's get past this. I don't want this being my only hang up. All right. So push pull. This is going to go down to 30 seconds. So I'm going to push it down 0.03125, and then I'm going to hit the move tool, grab it on the edge, and move it up to there to create that little countersink. Okay, next one, push pull. This one goes all the way through. It's not wanting to register. 0.078125. This one goes 0.03125, and I'll stop talking here in a second so you don't have to hear that repeated over and over and over again. 0.03125. Move. All right, next. Man, I thought I could bulk do that. Such a shame. All right, you get the gist on this. I don't think I'm going to do all 12. I just need the hole placements. I got the circles where they need to be. I'll just do these first 4. Give me just a second. 0.03125. Okay. Oh. All right. So did the first 3. We'll just leave that. So that's how we do a countersink, blah, blah, blah. All right. Now on these parts, I have a kit of 4 of these, right? So I have a kit of 4. Now, my question to myself is how far apart? I mean, for my clamping and everything, how far apart do I want to be? How much versatility, how little versatility and all, what's going to happen? Well, here's what I'm wanting to happen. Let me just give you a little bit of insight on what I'm wanting to do. Between my T-tracks, again, so you understand, recently on my 2440, I have the black box vacuum, the Storm vacuum for vacuum hold down, and I have a plenum that for that vacuum to vacuum hold down and everything. And I would like that in between my T-tracks that I have the grid for the vacuum channels and all to be in between my T-tracks and everything, so I have my different zones for vacuum hold down. But when I'm not using I don't want my vacuum running all the time. It's loud, right? It with all rights, it should be. But I don't want to run the vacuum all the time. I want to, sometimes I just want to use two-sided tape and CA glue, and sometimes I want to use clamps. I don't want to always use vacuum and everything, because there just might be days I want some peace and quiet besides listening to the hum of my spindle cutting wood, right? Who knows? Currently, my vacuum, the Storm vacuum, is mounted or positioned under the CNC table, and it's loud. And so you understand, really, really, really understand visually what I'm referring to. Give me just a second here. Wow. Wise men say. Do I have that video unlisted? Let me find it here real quick. Give me 2 seconds, ladies and gentlemen. Let's go to... This is what I love about being on Restream. I don't have to worry about switching channels. Unlisted. Okie dokie. Oh, hold on now. All right, let me put this on the screen here just so you can see. Let's go full screen. Let me see where, make sure you all are seeing this. All right, let's hide that for a second. So this is the Storm black box vacuum, right? And then the plenum on the 2440, you can see it in the background there. Let me see if I can. So the vacuum ports are on the back, and the vacuum gets pulled down through. I've got blast gates underneath and all that stuff. Currently, right now, I only have 2 zones and all. I'm going to have more zones. I want to have separation because I'd like to make my zones smaller and everything. And then the spoil board sits on top of that, gets vacuumed down, and when it's vacuumed down, it just is locked in, right? So I like it. I love my vacuum clamp and all that stuff, but it's noisy, right? Right? It's noisy. So what I want is this plenum, my plenum design, this grid right here. I want that in my new wasteboard. Now, on the wasteboard that we're going to be making tonight, it's just going to be a plain wasteboard, right, without the plenum design and all that stuff. But in between the T-tracks, just know in between my T-tracks, I'm going to be cutting this grid in, and then my vacuum is going to connect to the back side of it and all that stuff to be pulling vacuum in between my T-tracks, right? So this whole plenum here has been sealed, believe it or not. It's MDF, right? So we can't lose vacuum through it, right? I would prefer it to be HDPE or something like that, but spent $160 on a sheet of HDPE, and they sold me a bent warp sheet, and I could never get it flat again. And I bought it. I bought it, and I looked. I said, oh, it'll be okay, and it was never okay. That sheet, it still looks like a banana sitting on top of one of my CNCs in the back, thinking that if I heat it up in an oven or if I heat it here, it'll flatten out. Shoot. No, it was a waste of $160 is what it was. Anyway, so I had to use MDF. And so they had to be sealed on backside, sides, all in the grooves and channels and all that stuff. And I actually used a mixture of Mod Podge glue and water diluted, Mod Podge diluted in some water, kind of a mixture, 80-20 kind of mixture. And also I could take a brush and brush it on, and it sealed every edge, nook and cranny and all. And I did 3 coats of it. And I don't lose any vacuum, right? So long story short, I'm going to have to repeat that process again. But this is what I want. This grid is what I want in between my T-tracks, right? Eventually. Right now, we're not going to do that. I'm going to get everything laid out. But I just kind of giving you my future, the reason why I'm changing to this design with the T-tracks on, what my plan is. Because right now, if you look in this video, let me go to here. I have a 3/4 inch wasteboard, which is the plenum. And then I have a 5/8 inch wasteboard, which has been surfaced on both sides so vacuum can pull through. That's my spoil board, right? So that's my spoil board right there. And that's my cut. The reason why it's not wide as the table is because my cutting area on the CNC is only 18 by 24. So that was a lie, 24 by 40. So this is the 24 by 40, right? So it's 24 by 36 actually. But so that thickness there, now I've got 3/4 plus 5/8, and then when I put a 1 inch board or 1.5 inch board or something on there, you know, all that stuff is starting to add up and reduce, you know, my travel and all that stuff, and that's fine. I've got plenty of room, but I want to see if I can have aluminum T-tracks. I can have my plenum in there for when I do want to use the vacuum. And I don't need the MDF wasteboard over it. I can just set the parts on and just hold them down and everything. I don't need that wasteboard. But if I do want to use the wasteboard, it's something I can take on and put off, you know, no big deal. But it's going to, if I took my wasteboard off right now, off this table, it's just the plenum. There's nothing there for me to put clamps in, right? Those are grids. It's a grid system, right? There's nothing there for me to clamp to. So I'm you know, using, you know, CA glue and painter's tape, and the CA glue and painter's tape, it's only got those little squares to hold on to, and it holds fine, nothing wrong. I haven't had any issues with it and all. But I want a better system. That's why we're doing this tonight. That's why we're going through that trouble. All right, let's get back to it. Okay, so let's really quickly, bear with me just a second. Let me switch back to... Okay. Okie dokie. All right, so now let's delete all the guides again. So my thought process is that if I use the 4-piece kit, that gives me 4 T-tracks, you know, across the front for clamping and combinations and things like that. And that gives me wider spaces for my plenum, for my vacuum clamping and stuff. So for more vacuum for hold down, so they're not so small or narrow, right? Versus 4 versus 5, and all that good jazz, right? So I think I'm going to stick with 4. I may add a 5th one in, but right now we're going to say no. Okay. So with that being said, coming back here, this layout, I'm going to have I'm not going to have a T-track in the center like there is one in the table. I'm not going to have a T-track in the center. Sorry, I'm getting tongue-tied. All right, so what I want to do is I want to kind of, I'm making this based on my machine, right? So you would kind of you could change the design. I'll make the design available and all that. But all right, hold on. Let me stop right there real quick. Brooks, maybe set some weights on the Florida sun. I put it out in the Florida sun on an 82-day degree on a dead flat surface. Dead flat surface. Make sure the surface is absolutely flat, right? And it heats up, and you'll see it relax over the day, right? You'll see it relax. Soon as it cools down, boop, pops right back up. I crap you not. I'm like, what? Because I look at it and I'm like, oh man, that's flat, you know, right? You know, in the heat and everything. And then, you know, it just all of a sudden, you'll see the sides lift back up and it curls back up. Oh, it upsets me because it's a lot of money, right? 160 ain't something to sneeze at. All right, anyway, so that I tried that. And I thought, man, there's got to be a way to flatten this out, but there is no way. Once it's warped, it's warped. All right, let's. So here's the deal. From my table to center, I have a 24-inch cutting area. My CNC center of my router bit can only get 24 inches. Okay, so that means the table is 30 inches wide. My CNC table on this particular machine now, this is a 2440. It's got a 30-inch wide table, 48 inches long, but of that, there's a 24 by 40 inch cutting area. It's my mid-size hobby unit. And so on this particular unit here, I want to kind of stay within where my T-tracks are. I want to kind of stay within my clamping area, or just right on the edge, so I can I can get full maximum distance, but I can have clamps out on the side. So what I want to do is I'm going to take a guideline, okay, from the center of the table, and I really need to let me move this out of the way real quick. Move out of the way there. All right, and let me come in here and let me get rid of these guidelines out of the way. Get rid of that one, and that one. Okay, so from the center of my table, okay, from the center of my table, I'm going to just pull a ruler out here, and from the edge, I'm going to pull a line to that center. Okay, so we should be able to see that there. Now, from here, 24 inches is 12 and 12, right? So I'm going to come over here and pull a 12-inch line right there, and I'm going to come over here and pull a 12-inch line. All right, so that is my 24-inch range, okay? Now, I'm going to move this over onto that line, and you'll see that it almost lines up, not quite, but almost lines up right with the other T-track here and everything. And I could, if I wanted to, I could be like right over the other T-track, but and if I did that, if I went over the T-track here and all, I wouldn't really need to use my nut inserts. I could just have a bolt go all the way through and then into the T-track. That might be a smart, yeah, right? Yeah, why not? That's just, I won't have to flip it over. I won't have to flip it over and make the little pockets on the back side of the MDF and all that stuff. I can just go through hole, slide a nut in there, and mount it down. A T-nut, machine screw with enough length, because this is going to be countersunk in. And yeah, what the hell am I thinking? Okay, see, this is what happens when you're on the fly. All right, so let's go here. Camera, standard view front. Let's try that again. Camera, standard view right. There we go. Okay, so I'll leave that line there. But okay, so that'll be that. And then I'm going to hold down the, and let me do this real quick. Tape measure. I love the tape measure. I'll just grab and snap right to this, and it'll put a guideline there. Guideline there. Guideline there. So that way I can just hold down the control key, move, M for move, grab it right on the right corner here, Control key to move that and snap right up against. Well, I say that. There we go. Snap up against that one. Hold down the control key. Snap against that one. Hold down the control key and snap up against that one. All right. So, wonderful. Wonderful. Now, that leaves me a big area right here in the middle, and that's fine with me. It'll give me, when I do my zones and stuff, again, remember, like I said, I'm going to be kind of multitasking this piece. It's going to be a vacuum plenum too in the future. All right. Now, here's the deal. What I wanted to do, I want to make sure that it's thick. You know, I got a good, solid piece and everything. This is 3/8 of an inch, and I want to be below the surface, right? So if I move this down, right? Let's say I move this down, and I come down here, and I lower it down here another from there. Let me snap it there first and move it down another bit. Let's say I go down another 1/8. I need to surface, right? Surface. I got to surface the area and all. So I want to have enough room that I can surface, because now one of the things, I don't cut into my wasteboard, so I don't have to surface it all the time. If I go down another 3/16, 0.1875 right there, that still gives me, that still gives me 3/16 of, meat, that when my T-bolt's going to be in this T-track and everything. So I'm not really putting any pressure on this. All the pressure, clamping pressure and pulling up and everything, it's pulling on the T-bolt in this aluminum T-track down here, right? The pressure's on that, not on my MDF. So I don't have to worry about, I'm not, like going to blow out or anything like that, because that's aluminum T-track, right? You know what I mean? So this is great. Great for me. And that gives me 3/16 of an inch of material above the T-track that I can surface. Let's say I surface a 1/16 of an inch off, still have 1/8 of an inch of material above it. So when I'm carving or cutting out or whatever, I'm kissing my surface anyway, but I'm not beating up, or I'm not cutting into my aluminum T-track and all that stuff. Wonderful. All that happy stuff is all great. So now what I need to do is that's perfect. What I need to do is in here, I'm gonna pull this. So you can see that in there. All right. And then we're going to rinse and repeat. So the way I'll do this is I'll just bring a guideline down to the bottom of this so I have something to snap to. I will move the T-tracks. I'll move all three of them at the same time, so I don't have to. So I'll select this one, shift key that one and that one. I'm going to go move, grab it here and just snap right down to there. Okie dokie, dokie dokie. I will take a rectangle here, push pull that. Oops. First of all, make sure that you're still inside this group when you draw that rectangle, Laney. Let's do that again. Push, pull that. I'm going to just do this and type in 48 and hit enter. Come over here, R for rectangle. Draw this one. Push, pull, P, 48, enter. R for rectangle. Here, P for push, push it a little bit, 48, enter. All right. Now get out of that group. And there we go. So now this does quite a few things for me. This does a few things for me. So this particular hole right here is set up for a number 7 screw, right? And a wood screw. Now, I have a choice in this matter. My T-tracks in the 2440, they accept quarter 20. They don't accept 5/16. So quarter 20, T-nuts, T-bolts, hex head nuts, hex head bolts, either one, right? The if I'm going to use a number 7 machine screw, which again, I'll have to find out the dimensions of that. Let's say I'm going to use a number 7 machine screw, right? And I need to make sure that the nut I use in this T-track isn't going to spin and spin and spin and spin. You know, like I do not want to sit there with a drill or a hand screw and I'm tightening and nothing's happening, right? Because and all that. Now, I also don't want. I have some choices here. I got some things to think about. And this is the mechanic side of it as far as like what screws and all. That's where I have to kind of like, I got to test it and see what's going to work. I don't want to drill out the holes. I could drill out the holes, for a quarter 20 screw, right? But if I drill out the holes for a quarter 20 screw, it changes, like the head size isn't going to be the right head size for that angle and everything. The question is if this T-track, if I purchase it, if it's designed for a number 7 screw and that's what the manufacturer is saying to use, then the head is kind of sized for that, right? And all that stuff. So if I bore out the hole for a quarter 20, then my head's going to be off. And if I use a button head instead of a flat head and blah, 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 and this and that, then now I'm obstructing my T-track for my slots because I'm already low profile. So I just have to come up with the nut solution that's, not going to turn and all. Whatever I figure out, I can't figure it out right now or tonight or anything like that. But whatever I figure out, I'll let you know. But this, in a nutshell, let me delete all the guides. Okay. This will suit me quite well for a wasteboard, a very simple, like I said, I'm talking about very simple wasteboard, right? John Thompson says use your T-nuts in the machine screws. Yeah, so a machine screw and the T-nuts, as long as the T-nuts have enough length that, when they turn, they'll catch and not just spin, right? Because the T-nuts that I have, going back to what screen was it? Give me just a second here. Give me just a moment. the T-nuts that I have, you know, they're a M5 T-nut, right? And they have a length of 15 millimeters. And so we're talking a half inch, 0.59 inches. So let's look at my drawing. And let's measure. That's a half inch. It would be just spinning the surface, right? Let me see here. Half inch this way, but diagonal would be longer, right? Or would it actually spin sideways? So here, let me draw a T-nut. Hold on a second. I gotta draw this in. Hold on a minute. Here, hold on. We are at it's 0.59. So yeah, it would hit. It would hit. So I could use the T-nut. I could use that T-nut if I could find the right. I don't think a M5 screw is going to be the right size hole. But anyway, yes, I could use my T-nuts. I want to use my I want to use something that I don't have to go buy, spend another. And they're not expensive. I mean, heck, those T-nuts were only did I minimize or close the window? They're where are we at? I'm looking at price. $16 for 100 of them, right? So all right, so hold on a second. Let me answer this question really quickly. This is important here. So, dang, Laney, if I understand the assembly process, you need to align all those T-nuts, then lay the wasteboard lining up the T-nuts down at the T-tracks. Might be simpler, the whole aligning, that. So here's the deal. No, this wasteboard would be cut. It would be, the bolts would be put through with the T-nuts on the end of the bolts. And then you line them all up and slide it from one end of the table, and you just slide it all the way in, all the T-nuts in. And the only thing you have to do is make sure they're facing the right way. But they're going to be, so the bolts go through the T-track, nuts go on it, not before it's even on the table. Bolts go in, T-nuts go on, and then all I have to do is set it on the table. I got 2 inches, so I'll rest the front 2 inches before the first screw hole on the table, and then I'll line up all 4 of those T-bolts to slide in. And then every row, as I slide in up to every 4 inches, for the 12 holes, all I have to do is make sure the T-nuts are facing the right way, so they just slide right in. So I don't need to lay them out. I don't need to lay the screws out, put the wasteboard on, and put the bolts in and hope I hit the alignment. No, I'm not going to do all that. I just slide it in, slide it on with all the nuts and everything. That's how I do all my wasteboards. Yep. So all the bolts are through the T-track, all the nuts are on there and everything, and they're right, in. So when I set it on there, I just make sure they're all facing the right way, but it slides into the T-track, and then I tighten everything down once I'm all, squared up and all that stuff. Right? Tighten everything down. Yeah, so measure from the top of the bottom of the taper to the bottom of the lower track, and then get the length of screws. Yes, yep, get the proper length of screws and all that stuff for sure. Because here's another thing that I don't want to happen, right? When I'm tightening the screws down, and I want to bottom out into my T-track, because then it's not holding anything. It's sloppy, right? They got to be just the right height, that when I tighten down those screws into that T-track and they're countersunk, proper in that T-track, that the bottom of that screw is not bottoming out in my other T-track, or otherwise it'll never tighten. It'll never tighten. JR, yeah, you tried that on your 2440, and it was a pain because the 2440 has those button head screws and all, and that's why I don't want the button head screws. But it's I have put on and taken off so many wasteboards and all. The top of my screws they've been kind of almost filed down, if you will, and all. And another thing, I mean, for the most part, if I ever wanted to or whatever, I could always change out those screws, but I don't need to anymore. They slide on and off just fine for me now. But anyway, what JR was saying is on his 2440, when he was putting his wasteboard on, he tried what I said about sliding, just making sure all the T-nuts are lined up and then sliding it in, and it was a pain in the butt, right? So and that's because in the T-tracks, in these T-tracks here on the 2440, the screws are not countersunk. They're little button head screws, so they stick up a little bit. So there's only a very little bit of room for the bolt to slide through, but a 1/4-20 nut will go right over them and everything, and all that stuff. It's just sometimes they can catch if they're not, at the right angle. But with those flat T nuts, no problem. It'll go right on. So now, just to give you a general idea, now it's 10:22. We've been talking about this for a while. But this is so if a customer bought a machine, they need a simple wasteboard that they can they'll be able to clamp, 2-side tape. They'll be able to use hold downs, whatever they want. This is a very simple, very stable wasteboard. You can surface it, all that stuff, right? All that good jazz. So very, easy enough to do and everything. For me, let me see here. Bear with me just a second. Bear with me just a moment. Ba, 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 ba. Look for it. All right, auto save wasteboard. I need to save that. So file, save my changes. Okay, go back here. All right, let's see. Aluminum puck, wasteboard, panoramic hall table, horse stand, clamp, mantle, chessboard. Okay. My plenum, I don't know. I don't remember if I drew that in, I think I drew that in Aspire, but I don't have it on this computer. So, long story short, there's going to be a wall, and let's say that, just as an example, there's going to be a grid system that what's going to be the best way to do this? Give me just a minute. Offset. I'm just roughing this right now, just as an example. me see here. Let me look and see if I have that plenum in my Google Drive. Give me just 1 second. All right, so Spindle TV. My drive, Spindle TV files. Search my drive for plenum. Plenum. Yeah. Okay. All right, that's one. Oh, come on now. All right, download. Now, this is not the plenum by any means. This was my rough draft before the one I actually made, but it'll give you an idea. Let me hit undo, offset, undo, undo, undo. Okay, let me bring in this picture. Okay, so this grid system, imagine this grid system here. This was my rough draft before I ended up with the finished plenum that you saw in the video earlier. But this grid system here would be in between those T-tracks. But they wouldn't be like right up to the T-tracks now because it's got to be sealed so there's no air loss and stuff like that. So there's going to be, you know, there's going to be a boundary, right? So let's pretend that this is the area here. So within this area, it's going to have that grid system, right? But all the grid systems will be tied together, and I'll be able to add, you know, my zones and all that stuff proper and all. They'll be able to flow and all that stuff. But I'll show you what that looks like. Well, you know, when it's all said and done, I got to order in the T-tracks and everything. But setting that plenum aside now, I'm just kind of giving you what my plan is. This is the simple layout here, and it's going to reduce. I don't have to have. My first thought was I was going to have a piece of 1/2-inch MDF. I was going to set the T-tracks on top of that, and then have another 3/4-inch piece of MDF in between each of the T-tracks and all that stuff, so they kind of set down. And if you're not visual in descriptions and all, I'll show you what I'm talking about. If we go in here and type in CNC wasteboard, and we go to images, and we look at, let's say this image to be an example. Let's open this image in a new tab. And so let's say here, you know, the wasteboard down at the bottom, right? Let's say that's a 3/4-inch wasteboard, and then the T-tracks are mounted to that, and then there's another 3/4-inch strip, and it's mounted. Those individual strips are mounted in between the wasteboards and everything. Now, for me, that would be 1.5 inches of meat. You know, that I got. That's 1.5 inches, not counting how recessed my T-tracks are, but still to the top of that, you know, is 1.5 inches, and I'm losing that much material. I'm losing 3/4 of an inch of material on the top. The way that I'm going to do it here is I have 3/4 of an inch, and then if I do put a vacuum wasteboard that goes on and off, it's only 5/8 of an inch thick, 1/2 inch to 5/8 and everything, MDF. And so, and it's milled on both sides down to size. So it starts off as 3/4, but it's milled down to 5/8 and everything. So the MDF has to be able to breathe, right, to suck off through. So I can use the plenum. I can seal off the areas, and I can use the plenum without the wasteboard, or I can throw a wasteboard on top of it, just that covers it and vacuum pulls through the entire wasteboard, right? And all. So either way, just like I have now. And that's what my goal is with this. So in this area between 1, 2, 3, these areas right here, that's where my zones are going to be. So I can turn on left, right, or middle. And all I have to do is add that third blast gate instead of the 2. All right, so let's see here. The button head and trying to hold up the full sheet of MDF plus keeping the head aligned. Yeah, so hurt my knees, right? So just real quick. This right here, JR, that's absolutely true, right? So when putting on the wasteboard, having to make sure all the holes are lined up, right? So the original wasteboard and stuff, down on your knees, you're under the full sheet of the MDF, the wasteboard, right? You're under it, you're kind of holding it up with your back and head, and you got your arms out on the side, and you're sliding it in, and all at the same time, you're turning the nuts, right? You're sliding and turning the nuts, and you're sliding. So the weight of, is on your kind of on your knees and all. And so yeah, it hurts your knees for sure. It's here's an easier way, right? Because that's how I used to do it. That's how I used to do it. So the easier way is my back no longer needs to be the support. I have a roller stand. So the first 2 inches of the wasteboard where there's no screw holes sits on the table. The rest of it sits on a roller stand that's not far away. Just enough room in between the roller stand and the table for me to be able to get under there across, and turn the bolts, slide it, turn the bolts. So I'm only bending down, sliding in. I'm not getting down on my knees. I can. Doesn't matter, but, I have knee pads, and stuff like that, but, or, I have cushions or whatever. But anyway, I'm not underneath it. I used to be underneath it, holding and supporting the wasteboard while trying to slide it in and get everything turned. Now I have I got smart and I went to Harbor Freight and got a roller stand. So yeah, anyhow, I actually have a couple of roller stands, but, and they work great for when I'm tiling. All right, ladies and gentlemen, so this is where we're at, right? So basically, I am going from, let me grab this group, this, and this. Oops. Oh, come on. One more time. 1, 2, 3, 4. M for move, and I'm just going to move it off to the right here so that I can unhide all of the, unhide all of the original. So the original wasteboard, once again, it had T-slots milled into it, right? Entry holes, T-slots, and everything milled into it. This wasteboard just has T-tracks laid into it. $48, well worth it. Plus, the MDF. For the beginner, it's going to be an easy way, a simple and easy for the 2440 and 3648. Now, on my bigger table, my 4848, I just double it up, right? So I actually have a 48 by 48 sheet, and I'll have, I'll get 2 sets, right? And my 48 by 96, just keep adding to it. Now, if I decided that I wanted to add some cross connections for clamping and everything, if I decided, okay, if I laid out my zones, right, again, completely separate from this design, but if I laid out my zones and said, okay, so here's my zones and all for vacuum clamping, and then I want more additional clamping options here, I have those additional kits that I have those additional kits that have, where is it at? Right here, that have those additional pieces that allow for, you know, cross sections and all that. The only thing is now, if I do that, there's no T-tracks there to mount to, so I would have to put the inserts recessed underneath and all that stuff. I don't want to deal with any of that right now. I think that'll be enough for me. In heck, if I want to add a fifth T-track right down the middle, right? And then just have my zones being, you know, smaller in the middle, not have the big zone in the middle and just have, you know, another smaller zone or whatever, because the spacing is a little bit different and all. It's narrower in the middle there. I can add a fifth T-track, not a big deal, you know, that kind of thing. But this would be enough for, if I'm going to be using two-sided tape and CA glue, this wide area in the middle is perfect for me for my smaller parts that I'm doing. I got that plenty of flat area right there to do that. If I do my vacuum grid is only going to go so far. I haven't figured out how I'm going to lay that out just yet. All kinds. I have options, but this is the base wasteboard. Get you started, clamp your stuff down, you're good to go. Okay, that's what I wanted to kind of work through tonight. I wanted to take you with me on the journey. I know it wasn't really anything all exciting and interesting and stuff like that, but at least you got to see some SketchUp drawing, and you know, we made some T-track, right? Not a bad piece of T-track, right? And all of that good stuff. So John Tom said, what software does the VCarve use? It uses the Planet CNC TNG motion controller software for its controller software. And let me see here. Give me just a second. Ba, 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 ba. Give me just a second. I don't want to show commercials and all that stuff. Pause. So John Thompson, the Planet CNC TNG motion controller software is what the machine uses, and there's lots of customizations and stuff are available. This is a video of some of the newest updates that are coming out for customizing custom panels for manipulating G-code, altering G-code, and you know, warping G-code and stuff on the fly, or creating ripples and things like that. So you can customize the software with some, you know, Python coding and all that stuff. And it is it's got cameras and contrast sensor camera settings and things like that, creating slots, you know, and everything. So yeah, so that's the software that's used. Planet CNC TNG, the next generation. We used to use, back in the day, we used to use Mach 3, but it's kind of a pioneer. You know, Mach 3 has been around forever, but with that, it's been around forever. Hasn't changed much. If you know, it's open source, so there's all kinds of add-ons and everything that people have customized and made, and everything. And then Mach 4, they kind of shot themselves in the foot because they made it closed source. And so when you had Mach 4, it wasn't as good as Mach 3 because you didn't have access to all those additional add-ons that the users created and everything. And it just got to be too much to deal with and all that stuff. So we went to Planet CNC TNG motion controller software. It is great. It's a great hardware and software combination for 3D printing, CNC, plasma cutting, laser engraving, rotary axis engraving, and things like that. It handles up to 9 axes, the control boards, 9-axis control boards and everything. Great program. Love Planet CNC. Yeah. And it's phenomenal. Yeah, so JR, that new release for the Planet CNC is coming out soon. Not sure when, but yeah, it's going to be pretty interesting. Okie dokie, ladies and gentlemen. That is going to wrap us up for the evening. I want to thank you all for hanging out with me through the changing of our resolution and stuff on the video stream, and hanging out with me for this process. This gives me a base video to show somebody, on making a simple wasteboard. I'll be able to measure out the dimensions and write out instructions for them. I'll be able to give them the links to the T-Tracks on Amazon if they need to buy those, and write the instructions to make that simple wasteboard for their CNC machine. And it can be customized for both tables. On this one, I would recommend that they use the 3 of the 4 T-Tracks, or if they're going to use that, or unless they want to use 4, then they won't be on the mini carver. They won't be able to use the T-Tracks for the nuts. They'll have to do it at the recess. But I'll have that alternate plan for them as well too. And it's just going to be a much simpler solution. But for me, it creates a simpler solution so that I can add in my vacuum plenum to the design. And I can add in the black and plenum to the design. And I can kind of kill 2 birds with 1 stone. Because right now I don't have if I take my vacuum wasteboard off, if I don't want to use the vacuum, I don't have any way of holding anything down except for CA glue and painter's tape on that particular CNC machine. And I can do that, but it's on the grid, and it holds well, but it doesn't hold really, really well, right? So until I get some noise dampening stuff, yeah. So yes, loops, calls, and functions. You can do all of that, and in the software, the Planet CNC software. Yep. You can bookmark and just run certain sections of your G code. You can skip sections of your G code. Like if I just want to run this section and this section, I can bookmark those 2, and then I can just tell it to run bookmark to bookmark. So it'll just run the bookmarked areas and skip everything else. You can set up coordinates. So on my tables, my CNC tables, I have 3 and 4 of the I have 3 or 4 zones on my table called coordinate systems. I have 3 or 4 coordinate systems, and I have jigs that mount to each of those, so I can carve different things on the parts that I manufacture and stuff like that. So you can switch from one coordinate system to another in this software very quickly. I already have the black box vacuum connected to the 2440. JR, I already have the connected to 2440. While it could be used on the 4848, it's a little small for the 4848. You would need the Cyclone. It would be recommended to have the Cyclone model for the 4848 and the Hurricane model for the 5100. So the Cyclone model. While I could use the black box vacuum Storm that I have, the black box Storm on the on the 4848, I would only be able to run one zone at a time, because it's a bigger table. but the Cyclone would be ideal for that size. Yeah. All right. And I kept saying this, I said this before, but I believe that's everything, ladies and gentlemen. Y'all have a wonderful evening. Enjoy your weekend coming up. I believe it is Friday. We missed Thursday. We're here tonight. Thanks for joining me on your Friday night instead of out there partying and dancing at the club and living it up and all that stuff. That's what we should all be doing if we were young again. All to be young again. I don't miss the clubs, but I do miss the fun time with friends and all. But I'm just an old fuddy-duddy. I stay at home now. I have no life. All right, everybody. Y'all have a wonderful weekend. Enjoy it, and we'll see you next week. It'll be regular time, Thursday at 8 o'clock. This week was just a little odd because, again, my new dog got into a bad bush that the thorns on it were poisonous, gave her a big old infection under her chest, and so I've been dealing with that and her treatment and stuff, and it's time consuming, so it kind of threw me off last night. All right. Y'all have a wonderful evening. We'll catch you later. This was just a simple project, but it gets better, guys and girls. We're just kind of doing something simple tonight to show the process. We weren't even in the Vectric software, but we were in SketchUp, so check out SketchUp if you haven't ever before. And if you're looking for a free version of SketchUp, go check out jayscustomcreations.com. He's still got links to the free downloads for version 8. If you ever want to play with SketchUp, it's a pretty cool program. Jays, Jays, customcreations.com. Laney sent you. Say hi to Jay for me. All right, everybody. Have a great night. See you soon.